Hello everyone, we meet again in our science class. So today's topic we will discuss about the electromagnetism. Did you know that there are permanent magnets and some are just temporary magnet? A permanent magnet is a magnet that always has a persistent magnetic field which consists of the magnetic force. Magnet kekal ialah magnet yang sentiasa menghasilkan medan magnet yang mempunyai daya tarikan magnet secara berterusan. In the meanwhile, temporary magnet is a type of a magnet in which the magnetic field is produced by only when there is an electric current. Magnet sementara ialah magnet yang terhasil apabila hanya terdapat arus elektrik. So let's learn more detail about this topic. Electromagnet is a type of a magnet that has temporary magnetic field when electric current flow through it. Electromagnet usually consists of a wire and a current will flow through the wire, then creates the magnetic field. The magnetic field disappears once the electric current is turned off. This is an example of the use of electromagnetics used in electromagnet crane. This crane works by using the magnetic field that is created by the electric current that can be turned off and on whenever it is necessary. The electromagnet consists of the iron in the middle and rubbed with a wire around it. This is where the electric current will flow. When the switch is pressed by the crane operator, then the current will flow and produce a magnetic field here. Therefore, it will be able to function like a magnet that attracts the magnetic materials. Do you know what makes our school bell ring? Bell actually contains an electromagnet. Here is the insulated soft iron, which is wound around by the coil wire. When you press the switch of the bell, the electric current flow and turn the iron rods to become a magnet, which will then attract this soft iron strip to be near with the electromagnet. In the meanwhile, the hammer, which is attached to the soft iron strip, will go near to the gong and at the same time hit it to make a ring sound. When the soft iron strip gets attracted to the electromagnet, it will no longer touch the screw and breaks the circuits. When the circuit is break, there is no electric current flow. This will off the electromagnet and the soft iron strip will go back to its original position. Once the soft iron strip returns to its position, it will touch the screw and the current flow back to the circuits cause the electromagnet to produce magnetic field again. So this will be continued until no one press the switch anymore. The pattern of magnetic field depends on the shape of the conductor. A straight conductor will produce a concentric circle shape of a magnetic field. Konduktor yang lurus akan menghasilkan medan magnet yang berbentuk bulatan sepusat. The direction of magnetic field can be determined using a compass or with the right-hand grip rule. Arah medan magnet boleh ditentukan dengan menggunakan kompas ataupun petua genggaman tangan kanan. So this is how you use the right hand grip rule. Get your right hand grip and your thumb will point to the direction of electric current, while the other four fingers will show the direction of the magnetic field. Ibu jari ikut arah arus, 4 jari yang lain mengikut arah medan magnet. Look at this diagram. The flow of electric current is from positive terminal to the negative terminal of the dry cell. Electric current now flow from the top to the bottom of this cardboard. So your thumb will point downwards while the 4 other fingers will point to the direction of the magnetic field. Same like this picture. You can try get your pen and hold it by letting your thumb point downwards. You will find out your 4 fingers will show the direction of the magnetic field, which is clockwise direction. And when we reverse the direction of electric current, the direction of magnetic field also reverse. Apabila kita ubah arah arus elektrik, arah medan magnet juga berubah. Look at this second diagram. The direction of electric current now is from the bottom of the cardboard. By using the right-hand grip rule, the direction of the magnetic field now is anti-clockwise. A concentric circle shape of a magnetic field is formed by a straight conductor. When we place a compass surround the area, the compass needle will follow the direction of the magnetic field. This can be seen as in this picture. Remember, the direction of magnetic field depends on the direction of the electric current. Arah medan magnet bergantung kepada arah arus elektrik. This is a pattern of a magnetic field produced by a coil conductor. The concentric circle shape of a magnetic field produced at the both sides of the coil. Since this coil here is where the electric current flow into the cardboard, therefore when we use the right-hand grip rule, your thumb point to upwards to follow the direction of electric current. In the meanwhile, your 4 fingers show the direction of the magnetic field. It gives a result of anti-clockwise direction. On the right side of this coil, the electric current flow downwards. Therefore, your thumb also pointing downwards. Now the direction of the magnetic field is clockwise. So this is the direction of the magnetic field. This is the pattern of a magnetic field produced by solenoid. This is the tips that teacher would like to share with you all. The direction of a magnetic field that form in front of the solenoid depends on the direction of the electric current that flow into the solenoid. Sila ambil catatan, arah medan magnet yang terbentuk di hadapan solenoid ini bergantung kepada arah arus elektrik yang masuk. Remember this, in front, meaning that current in for the direction of the magnetic field that form in front of the solenoid. Let's say an electric current flow into this solenoid is from this direction. This will produce the direction of a magnetic field in front of the solenoid. Remember, current in for direction of a magnetic field in front of the solenoid. Therefore, by using the right-hand grip rule, the thumb follow the direction of the electric current. The 4 fingers show the direction of the magnetic field, and we will get the direction is clockwise. Next tips. Current out for the direction of the magnetic field form at the back of the solenoid. Sila ambil catatan, arah medan magnet yang terbentuk di belakang solenoid ini bergantung kepada arah arus yang keluar. Remember this, out, back, meaning that current out for the direction of the magnetic field formed at the back of the solenoid. Arus elektrik yang keluar adalah untuk arah medan magnet yang terbentuk di belakang solenoid. Let's say an electric current flow out from this solenoid in this direction. This will produce the direction of the magnetic field at the back of the solenoid. Therefore, by using the right-hand grip rule, your thumb is pointing to the direction of the electric current, while the other 4 fingers show the direction of the magnetic field. Then we will get the direction of the magnetic field is anti-clockwise. This is the full diagram show the pattern and the direction of the magnetic field that formed by a solenoid. Remember these tips. Direction current out is to show the direction of the magnetic field that formed back of the solenoid. Direction of the current in is showing the direction of the magnetic field that formed in front of the solenoid. Remember, out, back, out, back, out, back, in, front, in, front, in, front. This is how to determine the poles on the solenoid. Ini cara untuk menentukan kutub pada solenoid. Look in the direction of the electric current at the end of both sides of the solenoid. If the direction of the electric current is anti-clockwise, therefore the pole is a north pole. If the direction of the electric current is a clockwise, that will be the place for the south pole. Or you can hold the solenoid with your 4 fingers, follow the direction of the electric current, and where your thumb is point to, that will be the north pole, and the other end will be the place for the south pole. That's the end of our lesson. Do practice in order to be master in this topic. Bye. See you in next class.